Hello, Chrysorel again. In this video, we are going to learn how to implement the RPGStat system from scratch. In the last video, we've already seen the interfaces, so let's start by implementing those. The first interface that we need is IReadOnlyStat. This interface needs an onValueChanged event, an IReadOnly list of other read-only stats, and two float properties, base value and final value. Next, we need a variation of this interface, also called IReadOnlyStat, but this time with a generic parameter t. This interface will implement the one we just made, and the generic parameter needs to be constrained to be a struct and to implement the IStatModifierData interface. We don't have this interface yet, so let's create it. In this file, we'll actually make two interfaces, just like in the previous one. One of the interfaces will be just a basic IStatModifier interface, and the other will also be IStatModifierData with a generic parameter t. The generic variant will implement the non-generic one. It will also implement iComparable t and iEquatable t. In addition to that, we will constrain the t variable to be a struct and to itself also being an IStatModifierData t. With that done, we can go back and finish our read-only-stat interface. For this variant, we also need a read-only list of stats, but this time we will use the new keyword to hide the existing stats property from the other read-only-stat interface that we inherited from, and instead we expose our own, where the elements of the read-only list are not IReadOnlyStat, but instead are IReadOnlyStat t. We also want to expose a modifier's count property and a getModifiers function which receives an iList as input, which we will then fill with the stat modifiers that this stat contains. We also don't have the StatModifier struct yet, so let's implement that. It will need a generic parameter t. It will implement the iComparable and iEquatable interfaces so that we can compare it to other stat modifiers, and the t generic parameter will be constrained to be a struct and to implement the IStatModifierData t interface that we implemented just moments ago. Oh, and StatModifier struct should be read-only. In terms of public variables, we will need a float for the value of the modifier and a variable of the generic type t to hold the StatModifier data. We also need an additional private int variable that we will use to cache the hashcode of the modifier. Since the struct itself is read-only, all of its variables also have to be read-only. We make a constructor for it that receives the value and the data and assigns them to the corresponding public variables, and we calculate and cache the hashcode. In the RPGStat system, we use the hashcode of the modifiers a lot, so caching it gives us a noticeable performance improvement. After that, we implement the missing interfaces. For the compare_to function, first we use compare_to on the values of the modifiers. If the result of that comparison is 0, that means the values are equal, so instead we do compare_to on the data of both modifiers, and then we return whatever result we got. We can call a compare_to function on both floats and our data variable, because the float built-in type implements the iComparable interface to other floats, and our data variable, which is of generic type t, has also been constrained to being an IStatModifierData, and that interface also implements iComparable. For the equals method, we check if the value of our modifier is equal to the value of the modifier we are comparing against, and we do the same thing for the data. In case of the data variable, we can't use the double equal sign, but we can use the equals method that is implemented by the IEquatable interface. We should also implement the equals override that receives an object as a parameter, and the getHashCode override. The equals override will just check if the object that we are comparing against is actually of type StatModifier and if it is, it will call the equals method we implemented right above. The getHashCode function will just return the hashcode that we saved in the constructor. For convenience, we will also implement the equals and not equals operator overloads. This time I'm talking about the double equal sign and the exclamation mark equal sign. When you implement one of these operator overloads, you will get a compiler error until you implement both of them. That's why you see the red squiggly lines when I just implemented the double equal sign. And for these functions, we just call the equals method from the IEquatable implementation. Of course, for the not equals variant, we need to negate that call as well. The next interface that we need is the IStat interface. This interface will be similar to the IReadOnlyStat that we just created, but this one will expose and potentially hide members of the other interface in order to make them writable. To be more specific, this interface will implement the IReadOnly interface. We will then also expose a stats property, and we need to use the new keyword for it in order to hide the stats property from the read-only variant. And in this version, instead of exposing a read-only list of read-only stats, we expose a read-only list of IStat. That means each stat in that list is writable. We also expose our own base value property and hide the inherited base value property, and in this case, instead of the property being get only, it's get and set. Lastly, we expose a clear method. Once again, we will also implement a version of this interface with a generic t parameter. Just like in the read-only-stat variant, the t parameter will need to be constrained to be a struct and to be an IStatModiferData t. For the variables of this interface, we once again expose a stats property using the new keyword to hide the inherited variants. For this one, the elements in the list will be of type IStatT, and by having the generic t parameter of type StatModiferData, we are now able to expose functions that allows the user to add and remove modifiers. So we expose an add modifier function, a remove modifier function, and a remove all modifiers that as a parameter simply receives an object that implements IEquatable, which means users have multiple different ways to implement this IEquatable interface in any way they like in order to remove stat modifiers that match any arbitrary rules that they choose. We also make this IEquatable parameter a generic parameter, which gives us the ability to implement the IEquatable interface in a struct, for example, and you can pass that struct safely to this method without causing boxing of the struct when converting it to the interface. The generic IStat interface should also implement the non-generic version. Finally, we can move on to the meat and potatoes of this video and start implementing a stat class. There are two main stat classes in this system, and the first one that we will implement we are going to call SimpleStat. This will be a stat that does not contain other stats, it simply contains modifiers. It will be a generic class, and it will implement the generic IStat interface, and as always, the generic t parameter will be constrained to be a struct and to implement the IStatModiferData interface. We will store modifiers in a dictionary, and the key for that dictionary will be the stat modifier itself, and the value will be how many of those stat modifiers exist. There are no restrictions on adding stat modifiers to a stat, which means multiple modifiers with the exact same values could be added multiple times. In terms of other private variables, we are going to need a bool isDirty flag. We are going to need floats for base value and current value. And we are going to need an int modifiers count to keep track of the total amount of modifiers that are in the stat. In terms of public variables and properties, and in order to implement the interface, we will need an onValueChanged event. We will need a base value property with get and set accessors. For the get accessor, we will just return the base value private variable that we just declared. And for the set accessor, we will call a set base value function that we will create in a second. We'll also need a final value property with just a get accessor. And here we will also call a get final value function that we will create in a second. And lastly, we need a modifiers count property that just returns the modifiers count private variable. Let's create the set base value and get final value functions to not have compiler errors, but we won't implement them fully just yet. We will leave that for a bit later. Let's start implementing the rest of the IStat interface, and we will start by the IReadOnlyStat properties. Since SimpleStat is a class that actually doesn't contain any stats, we don't want to expose a public list of stats in the class itself. So instead, in order to conform to the interface, we will implement all of these properties as explicit interface implementations. What that means is that these properties will only be accessible if we cast the SimpleStat class directly to one of the interface types. And also, since this class is not supposed to contain other stats, for all of these properties, we will just return an empty array of the corresponding type. Let's make a constructor for this class. The input parameter for this constructor will just be the base value. And in the body of the constructor, we just need to assign the base value that we receive to our private float base value variable. And we can also assign the current value to be the base value as well, since at this point in time, we don't have any modifiers yet. We can implement the remaining interface methods now. And let's make a few private helper functions, because there's a few functionalities that we'll need to reuse a few times. Let's start with the addModifier method. So the structure for this function will be that we need to add the modifier to the dictionary. Then we will need to perform some math operation that will calculate the final value for us, but we don't know what that operation is yet. As such, we will implement that in an abstract method that inheritors of this class will need to implement. So we'll make an add operation function, a remove operation function, and similarly, we also need a function to set the base value. And the arguments for all of these will be very similar. When we are adding or removing modifiers, we pass the modifier that we are adding or removing, and then we pass the base value, current value, and as an out variable, we want to retrieve the new value for the stat. When it comes to changing the base value, the first parameter, instead of being the modifier, is simply going to be the new base value that we want to change to. In addition to that, all of these functions will return a boolean which will indicate to us if we are supposed to set the isDirty flag or not. The idea for this is that most SimpleStats will be able to calculate their final values just from these methods alone. We don't need to set the dirty flag, and we don't need to recalculate all the modifiers. We just need to calculate this one. However, there can be exceptions. Some particular implementations of the SimpleStat class may not be able to calculate the final value just based on these variables, and we may need to recalculate the entire modifiers list, and that's what the boolean for isDirty is for. Going back to the public addModifier method, we call our private add method, which we will implement in just a second, but it will add the modifier to the dictionary. Then we call the addOperationAbstract method. And lastly, we will create one final private helper method called checkValueChanged. And this one will receive the isDirty flag and the new value and check if the final value of the modifier actually needs to be modified or not. And if it does, it will call the onValueChanged event. When assigning the isDirty variable, we will do a compound assignment as an OR equals. That's basically the same thing as doing a plus equals for a number variable, but in this case, since it's a Boolean variable, it's an OR instead. So the value of the class variable isDirty will only be set to true if the new isDirty is also true, otherwise it will remain unchanged. Now that we have this helper method, we can call it in addModifier, and following the same structure, we can implement the removeModifier method. We just have to change the add call to a remove call instead, and we need to return true and false where appropriate in order to match the signature of this method. Returning true means that we were able to remove the requested modifier, and returning false means that we couldn't. Let's implement the add and remove functions now. For the add function, first we check if the modifier is already in the dictionary by calling try_getValue. If it isn't, that's okay, because the count variable will return 0, so we just assign that modifier to the dictionary, incrementing count by 1. We also increment the modifier's count variable by 1 in order to correctly keep track of the total number of modifiers that this stat contains. For the remove function, we again call try_getValue to check if the modifier already exists in the dictionary, but this time we actually wrap it in an if statement, because if it isn't in the dictionary, then there's nothing to remove and we can just return false. However, if the modifier is in the dictionary, then we need to decrement the modifier's count by 1, and we need to check how many of these modifiers exist in the dictionary. If it's more than 1, once again we decrement the count by 1 and we'd return true. If there's just one of these modifiers in the dictionary, that means this is the last one, so we can just call the remove function to remove this key entirely from the dictionary. Let's do remove all modifiers now. This is going to be one of the biggest functions of this class, so let's take it step by step. We'll need a few local variables. An int removedCount to keep track of how many modifiers we managed to remove. A bool isDirty to check if removing any of these modifiers requires setting the isDirty flag. A float new value, which will start out to be the current value, and it will keep track of any changes made to the value of the modifier. And an int keysCount, which will have the number of distinct modifiers in the dictionary. So we rent an array of StatModifiers from the array pool, which we will call keys, and then we will call modifiers.keys.copy_to, passing in the keys array that we just got and telling it to start at index 0, and this will copy all of the modifiers in the dictionary to our array. Now we have to keep in mind that renting arrays from the array pool can give us arrays that are bigger than what we requested, but never smaller, and so from now on we will always use the keysCount variable when working with the array instead of the array length. Now we iterate through this array, checking if the match variable that was passed in as a parameter to this function actually matches with each modifier in the array, and we do that by calling the equals method, since the match variable implements IEquatable. Then we remove that modifier from the dictionary, and we save how many of those modifiers existed in the dictionary before removing it in the count variable. And then, for each modifier removed, we call the remove operation. We also increment our removed count variable that we declared at the top of the function with the number of modifiers that we removed. When we are done with this part, we can clear the array, and once again we will use the keysCount variable as the size of the array, because we only need to clear the portion of the array that we actually used, and then we can return the array to the pool. After that, we decrement our modifiers count class variable, which holds the total number of modifiers that this stat has, and we decrement it by the number of modifiers that we managed to remove. Then we can call the checkValueChanged, passing in isDirty and the new value. And lastly, we return the number of removed modifiers. For the getModifiers function, we will very easily iterate through the entire dictionary, and for each element in the dictionary we will do an additional for loop using item.value as the size, because that gives us how many copies of each modifier exist. And then we just add the key in the key value pair to the results list as many times as we need to. For the clear method, we clear the dictionary, set the modifiers count to 0, and call checkValueChanged, passing in false for the isDirty variable, and we pass the base value as the new value that we want for the stat's current value. There's only two functions left to implement, so let's do setBaseValue. First we need to check if the base value that we want is actually different from the current one. If it is, we can call the setBaseValueAbstract method that we made a few moments ago. Then we assign our class variable base value to the value that was passed in as a parameter to this function. And lastly, we call the checkValueChanged, passing in the isDirty and new value variables. And to finish the SimpleStat class, we need to implement the getFinalValue method. Most of it is already implemented, so we just check if the isDirty flag is set. If it is, we can set it to false. We can assign the current value to be the base value, and now we implement the missing bit, which is we need to iterate through all of the modifiers. For each modifier in the dictionary, we iterate once again with a for loop using item.value as the size, and so for each copy of that modifier in the dictionary, we call the add operation abstract method that we made. And for this particular case, we don't need to store the isDirty flag. For the modifier, we pass in item.key. For the other variables, we pass in base value and current value as normal. But for the out parameter, we pass in current value again, meaning that the result of this operation will be stored in our current value variable. And of course, at the end of the function, we just return the current value, whatever it is. That will be all for this video. Please join me in the next one, where we will continue the implementation of the RPG stat system.